Hello, this is Maria from Math Mammoth, and this is Matty, my mascot. In this lesson, we're continuing studying quadrilaterals. Let's first look at some definitions and how we mark these pictures of quadrilaterals. We have parallelogram. What is its definition? A parallelogram is a four-sided shape, a quadrilateral that has two pairs of parallel sides. Let me sketch one. If I have a side here, then somewhere else I have to draw a parallel side, like that. And in a parallelogram, the opposite sides are the same length also, though that is not part of the definition, but we know that. And then these two other sides also end up being parallel. Let's try another one. As far as marking a parallelogram, we would mark the parallel sides with little arrows. So these two sides are parallel, they go in the same direction. And then these two other sides also are parallel, and here I will use a double arrow. Then a square. What's the definition of a square? You might already know it. In a square, we have four sides the same length, and then we have some special angles. Do you remember? Yeah, Matthew remembers. They are right angles. So my sketch is, a little bit inaccurate. We mark the right angles with these little squares. So there's four right angles. Each side is the same length, or the sides are congruent. We mark the sides and show that they are the same length by putting like a little tick mark through each side. So these tick marks show that each side is the same length. Then a rectangle. In a rectangle, you probably know, we have four right angles, like that. The opposite sides are parallel and are the same length. However, we don't normally mark it because it is not part of the definition. If I want to mark it, then I would do it this way. This side and this side are congruent, so I mark a little tick mark. And then here I mark a double tick mark here and here, so that they are shown to be congruent too. In a kite, the adjacent sides are congruent, and it has two pairs of such sides. In other words, I have two sides that are the same length, or congruent, and then two other sides that are the same length, but some different length, possibly from the first two sides. And to mark it, I would put little tick marks here to show that these two sides are the same length, and then also double tick marks through these to show that these two sides are the same length. A rhombus has four sides that are congruent, or the same length. And it ends up that the opposite sides are parallel. It is also a parallelogram. But that's how we mark that all four sides are congruent. And then lastly, in a trapezoid, we have one pair of parallel sides. So maybe like one side is here, another one is here, it's parallel, and then the two other sides go like that. And to mark it, then we use these little arrows. This side is parallel to this side. A certain quadrilateral has two pairs of parallel sides, and its sides measure 4 inches, 4 inches, 4 inches, and 4 inches. What kind of quadrilateral is it? We just looked at all these definitions. Can you tell? What would we call this kind of quadrilateral? We notice that all of its sides are the same length. So if I sketch it, if one side is this, then another side has to be the same length, and it turns out that it has to go like this then, approximately. This is just a sketch. Or it could be like this. It's called a rhombus, right? You remembered? Lastly, draw a parallelogram with 5 centimeter and 8 centimeter sides. Can you draw several different kinds? Okay, I'm just gonna sketch these. I'm not gonna measure exactly, but you could try this exercise on paper with a ruler. So if I want to draw a parallelogram, okay, it is two pairs of parallel sides, and the opposite sides are the same length. So therefore I know that the other two sides are 5 and 8 centimeters. But I could, for example, let's say I started by drawing this 8 centimeter side, and then the 5 centimeter side, it's not going to be opposite of it, it's going to be right next to it somewhere, like anywhere, right? It doesn't say anything about the angle here. So I could draw the 5 centimeter side going anywhere, maybe this way. And now, being a parallelogram, this side will be parallel to that. It goes like that. And then lastly, the other 8 centimeter side. But could I draw a different kind? Let's say I still started with the 8 centimeter side. This 5 centimeter side, you imagine it can go any direction here. Since we're not told anything about the angles, it could go this way, like that. 5 centimeters here. And then the other sides would go like this. Get a rectangle. And a rectangle is still a parallelogram because in it, the opposite sides are parallel. So, yes, you can draw several different kinds. In fact, you can draw an infinite number of different kinds. Oops! Matty appeared. How did you come there? Ah, you wanna go play? Aha! Let's move Matty. There we go. Matty's like in a box. Now he can go sailing in a parallelogram or flying in a parallelogram or something, right? Yes. Alright, I hope this was helpful.